Let's go for Lab 12. Task 1. Caution. One-sided t-test begins with investigation of averages. Only if the averages are in agreement with the assertion do we use Excel to compute p-value. If averages are not in agreement, the test is automatically deemed inconsistent and no p-value is computed. It is commonly believed that as men get older, they accumulate more body fat. Use man body data and your statistical expertise to answer the question. Is this a reasonable belief? Here it says it is commonly believed that men gets older, they accumulate more body fat. So there is a relationship between people getting older and accumulating more body fat. So that's the case of regression. Here I have uploaded the man body data. Select the age and body fat. Okay, Control C, and in a new worksheet paste it. So let's go for data analysis, regression. Okay, input Y range. So more age, more body fat. That means Y range is body fat. For X range, B1 up to B253. Okay, click on labels and click on OK. Thus we get a regression table. The p-value is this one, which is very less, 2.34 to the power -6. So that's a very small p-value. So since p-value is small, we are confident that slope is not 0. That would be an appropriate thing. Averages are different. No, that's not the correct answer. If it were two-tail t-test, then we would go for this one. This is not the correct answer. So A is the correct answer. Yes, I am confident that the above belief is reasonable. So that's it. Let's go for task 2. It is commonly believed that cities with wind speed 10 or more have average temperature higher than 40. Use pollution data and your statistical expertise to answer the questions. Is this a reasonable belief? Cities with wind speed 10 or more have higher average temperature than 40. So that's the case of confidence interval, since we are comparing the average of a group of data with a fixed number 40. Okay, here I have uploaded the pollution data. First let us custom sort this data. Sort and filter, custom sort by using wind. Okay, wind speed more than 10. So these are the data. From 29 up to 42 are the cities whose wind speed is 10 or more than 10, and we need to check whether the temperature is greater than 40 or not. Okay, so average of this one, average temperature of these cities is 50.03. 50.03, 0357, and standard deviation is equals to STDEV 29, okay, up to 42. So that's standard deviation. And now margin of error would be equals confidence dot t, alpha is 0.05, that's 95% confidence. Standard deviation is 7.40, comma, size is, so total data is 14. Okay, so that's the margin of error, and confidence interval would be equals average minus margin of error. So that's the left endpoint, and right endpoint is equal average plus margin of error. So that's 45.75 up to 54.31. Since it's confidence interval, so we are not talking about p-values. Okay, so none of these. And conclusion, yes, I am confident that the above belief is correct, since the confidence interval is higher than 40. 45 is the lower limit and 54 is the higher limit, so that's why we are confident above belief is correct by 95%. Now let's go for task 3. Refer to the box plot, answer the question 7 to 9. Here 30 to 45, 46 to 59, 60 plus, these are the age groups, and their blood pressure is shown by this box plot. What is the approximate median for 30 to 45 group? Approximate median would be 100, 150, slightly less than 150. So none of these. Which of the three groups have third quartile approximately 170? Third quartile 170 is 60 plus group. This is the third quartile, 60 plus group. And which of the group has the highest range? Highest range means maximum minus minimum. So maximum minus minimum is this one. So this minus this, this minus this, and this minus this. So you can see that 46 to 59, they have the maximum range. Okay, 185 up to 125 or 130. So 46 to 59. We have already done this kind of tutorial. Okay, so please go through lecture number 27 and 28. So you'll get this tutorial there. Let's go for task 4. A random experiment was conducted where person A tossed 5 coins and recorded the number of heads. Person B rolled 2 dice and recorded the number of smaller number out of 2 dice. Simulate this scenario. Use 10,000 long columns to answer 10 to the 13. First, let us teach Excel to roll a dice by making this table. Okay, since while rolling a die we get 6 outcomes. We may get 6 outcomes, and their individual probability is 1/6 for all of this. And let's teach how to toss a coin. Getting 0 is getting tail, and getting 1 is getting a head, and their probability is 0.5 each. Okay. Person A tosses 5 coins and records the number of heads. That means we are summing up. Okay. So data analysis, go for random number generation, click on OK. Go for discrete distribution. Number of variables is 5 since we are tossing 5 coins, and 10,000 columns. 10,000 columns. Value and probability input range is this one. Okay, and click on OK. Random seed, leave it empty. Click on OK. Alright, so we get 5 columns. That means these are the columns for 5 coins, and if you go to the end, then there is 10,000 tosses of the coin. Let us record the number of heads in each toss of 5 coins. Sum is this one, A1 up to E1, so that's 3. And now hover on the right bottom and double click, so you get this thing. Okay, so that's fine. Then since we have tossed 5 coins, so the appropriate number of pins would be 0, 1, 2, 3, 4, 5. Okay, these are the 6 outputs that we can get. The sum of these 5 coins would be these things. Okay, now let's make the frequency table. Data analysis, go for histogram, click on OK. Bin range is this one. Okay, so that's fine. Now input range is F1 up to $F$10,000, and bin range is G1 up to G6, this one. Click on OK. Let us roll 2 dice and record the smaller number. Data analysis, random number generation, click on OK. Number of variables is 2 since we are rolling 2 dice, and random number is 10,000. Discrete distribution, and value and probability input range is from A2 up to B7. Okay, click on OK. Then we get this thing. So equals minimum of A1 and B1. That's all. Now double click left, so you can see at the end there's this one. So now let us compute the bins. Bins is from 1 2 3 4 5 6. Okay, since there are 6 outputs and the list would be 1 2 3 4 5 6. So go to data analysis, histogram. Let us make the frequency table, and this the input range is C. Okay, that records the minimum C, and C1 up to C10,000, and this is D1 up to D6. Right, click on OK. Now this is for dice, and worksheet 3 was for coins. Okay, now let's go to the question. Which of the two person is more likely to get number 1? So person A, who tosses the coins, will get 1576 and 2457. So person B, okay, person B will be the one. Which of the two persons will have higher variation in their outcomes, that is higher standard deviation? So let me go for person A, which rolls this much die, okay, equals to STDEV. This was from F1 up to F10,000, 100,000, 10,000. Okay, so that's 1.11. And then let's go for worksheet number 4 and find the standard deviation here also. This is C1 up to C10,000. 1.40. So of course B has the higher standard deviation. Person B has the higher standard deviation. What is the probability that a person A obtains number 5 or 6? Person A obtains 5 or 6. Person A is tossing coins, so 5 or 6. Since 6 is not possible for person A, since the highest outcome is 5, so we would just go for 317 divided by 10,000. That's 3%. Okay, so equals 317 divided by 10,000. So that's 0.0317. That means 3%, 3.17%, about 3%. Which of the persons has higher probability of getting number 3 or larger? For person A, number 3 or larger, let's add all of this, equals sum. So the array would be 3 to 5 and divided by 10,000. So the 0.5 is the 54% probability is for A. Now for person rolling dice, let's go for equals to sum 3 or higher, this one, divided by 10,000, 4368. So person A. Okay, now let's go to task 5. The following videos might be helpful. For a healthy human, our body temperature follows a normal distribution with a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.26 degrees Fahrenheit. For an individual suffering with common cold, the average body temperature is 100.6 degree Fahrenheit and standard deviation is 0.54 degrees Fahrenheit. Simulate 10,000 healthy and 10,000 unhealthy individuals and answer question 14 to 16. Okay, so data analysis, go for random number generation, click on OK. So we want normal distribution since this is normal distribution. Okay. Number of variable is 1. 10,000 healthy people, normal distribution, mean is 98.2 and standard deviation is 0.26. Click on OK. Then again for unhealthy people, 10,000 unhealthy people, data analysis, random number generation, 1, 10,000 normal, mean is 100.6 and standard deviation is 0.54. Click on OK. Alright, so this is unhealthy and this is healthy. So healthy and unhealthy people are found out. Okay, first before doing any problem, let us sort the data. Alright, so for healthy people, let us go to home, sort and filter smallest to largest. So that's fine. Now let's go for unhealthy data, unhealthy, sort and filter smallest to largest. Okay, that's fine. Now what is the approximate probability that a randomly picked healthy individual will have a body temperature below 98.4 degrees Fahrenheit? So let's go for healthy people, 98.4, control F, 98.4. so 98.4 is 7773. So below 98.4 means we need to go up to 7772. So the probability would be equals 7772. That's the total number of people who have body temperature lower than 98.4. Okay, divided by 10,000. So 77.72%. 77.72%. Now what would be a range which would contain 68% of the individuals having common cold? Having common cold means the people are unhealthy, right? Yeah, people are unhealthy. So let's go for unhealthy population, this one. Now here I would like to mention you that in Gaussian normal distribution, okay, let's go to this Wikipedia page and see the normal distribution, the Gaussian distributions Bell diagram. Okay, and we have discussed this before. So here you can see that this is mean and this distance is 1 standard deviation to the right and 1 standard deviation to the left. So from 1 standard deviation to the left up to 1 standard deviation to the right, we will get 68% of all the data. The total range of getting 68% data, approximately 68% data, would be mean minus 1 standard deviation, and the right endpoint would be mean plus 1 standard deviation. So let me write that down. So that would be range would be mean minus standard deviation for the left endpoint, and for the right endpoint mean plus standard deviation. Okay, so this is left endpoint and this is the right endpoint. For unhealthy people, mean is 100.6 and standard deviation equals to 0.54. Yeah, you can just go for that. So left endpoint would be equals 100 minus 0.54, 100.06, and this one is equals mean plus 0.54. So that's 101.14. So 100.06 up to 101.14. Okay. All right. What is the approximate probability that a randomly picked unhealthy individual would have body temperature below 99.04 degrees Fahrenheit? 99.0 degrees Fahrenheit. And 99.0 Fahrenheit means this one is 99.0. So 10 people have temperature less than 99 Fahrenheit. So that would be equals to 10 people divided by 10,000, 0.001. So less than 1%, about 1%. Here binomial distribution is given. Go for lecture number 27, the video of lecture number 27, and I have shown you how to work with binomial distribution in Excel, okay, without using this formula. Alright, so let us go for task 6. 5 friends took the final exam and the probability that each of them would get an A is 1/4. Use binomial distribution to answer the following question. We are interested in total number of A's among these 5 friends. So what are the N and P in this binomial model? So P, probability of getting an A is 1/4, means probability is 1/4. 5 friends means N equals to 5 and probability equals to 1/4. None of the above. What is the probability that 2 out of 5 friends got A's on the exam? So what is the probability that 2 out of 5 friends got A's on the exam? So for that, let us go for since the number of trials is 5, so we should go for 0, 1, 2, 3, 4. Okay. So success. Let me go for success equals to 0, success equals to 1, success equals to 2, success equals to 3, success equals to 4, and success equals to 5. Okay, so for that, here let us go for equals to binom dot distribution number S means 0, comma trials is 5, comma probability of success is 1/4, comma false, FALSE, false. Okay, so that's 0.2373. This one is also nearly the same thing, equals binom dot dist number of success is 1, comma number of trials is 5, comma probability of success is 1/4, comma cumulative is false, bracket close, 0.3955. success 2 is equals binom dot dist number of success is 2, trials is 5, 1/4 is the probability, and cumulative is false. Okay, so that's it. Fifth success for 5 is V equals binom success is 5. Okay, so I have done this thing for everything. Alright, now then what is the probability that 2 out of 5 friends got an A on the exam? So success is 2 out of 5, that means 0.2636. so that's our answer. Number 19, which of these is most likely to happen? None of the friends got an A. So this has 0.2373 probability. That's a good amount of probability, but we can't say that none of the friends got an A. All of them got A's? No. Only one friend got A. Only 3 friends got A's. So here you can see that the highest probability is 0.39. Okay, so we can say that only one friend got an A. So that's the most likely to happen. Okay, so that's it. Alright, so that ends the lab 12.